So in this video, we're going to be doing some curve sketching. So we're going to go back over everything we've done with these functions. We're going to deal with polynomials in this video and rationals in a later one, and find everything we need about the function from domain and asymptotes and intervals of increase and decrease and local max and min and concavity and points of inflection. And then we're going to use all of that to sketch the curve. So to do that, first thing you got to do is find our first and our second derivatives. So negative 4x cubed plus, and then that would be 24x squared. So our second derivative would now be negative 12x squared plus 48x. And remember, we can relax here because when you plug in your calculator, it gives us a picture. So we already know that we're going to be getting some relative extrema and some points of inflection. So all we have to do is verify it with our calculator. So there we have it. So to find local extrema, we used our first derivative. So let's set this equal to 0 and see what we get. So if we factor out negative 4x squared, we would end up with x minus 6. And so we end up with x equals 0 and x equals 6. So let's place those on our graph, 0 and 6. And the reason we haven't talked about domain is this is a polynomial. And so with polynomials, we already know our domain is from negative infinity to positive infinity. So we're going to be looking at everything. All right, and then we take our first derivative, something over here like a negative 100. First derivative of, say, 1. And then first derivative of 100. So if we take our function here, we already know it's negative, positive, and then whatever this gives us. So we know it's going to be negative, positive on every single one. We just have to decide with the last one. So what is it going to give us? Positive or negative. So if I plug in a negative 100 into this parenthesis, it would come out to be negative, meaning we have a positive, it's increasing. Let's move on to the next one. If I were to plug in 1, that would come out negative, which means we have a positive, which means it's increasing. All right, last one. If I plug in 100, that comes out to be positive, meaning we have a negative and it's decreasing. And if we check our calculator, you can see that that's what's happening. It's increasing and then decreasing. And I'm going to change the window here, as we don't need to go to negative 17,000. How about negative 100? And then hit graph. And that's a much better picture. So it's increasing to here, that's our 0. And then increasing here. And so let's verify that that's 6 and that's 0. So trace 0, enter. Correct. Trace 6, enter. It's off the screen. That's perfect. Exactly what we wanted. That means it's that highest point. And let's write those down. So it's 6, 8, 32. That's this point right here. This is 6, 8, 32. That is our critical point. And then for 0, let's just do it anyways. Trace 0. It's 400, so that is our critical point. So we have a critical number of 0 and 6 and critical points of 0, 400, and 6, 80, 32. Now, which of these is a local max and a local min? So it has to be increase, decrease to be a max. So that is a max. So increase, green. Increase, decrease, that's a local max of 832 at 6. We do not have a local min, because again, that needs to be decrease, increase. So there isn't one. And it's increasing from negative infinity to 6. And it's decreasing from 6 to infinity. And there we go. So now we have our first derivative taken care of. Let's now look at our second derivative. So if we set this one equal to 0 and we factor out negative 12x, we end up with x minus 4. And so we have, again, 0 and 4 is the other one. So we place those on the graph. And now we do the same thing with second derivative. All right, so a number to the left, let's do negative 100 again. Let's do 1 and let's do 100. So this is going to be negative and then negative, we find out. But we know our first one's negative, 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 and then we got to find out the other two. All right, so if I were to plug in negative 100 into here, that would come out negative, and the other one would come out negative, making this negative, which means we are concave down. Next one, 1, that would be positive, and negative, making it positive, which means we have concave up. And then the last one would be 100, so obviously positive and positive, making it negative and concave down. And so that should verify in our calculator as well. It's concave down, concave up. And then right at 4, so let's find 4, trace 4, right there, 652. So 4, 652. That's a perfect point of inflection. You can see it's concave down, concave up, and then concave down. So these are our points of inflection. So we have inflection points. They're all changed here. So we have inflection points at 0, 400, and then also at 4, 652, because there's a change in concavity. It went from red to green and green to red. Those are both inflection points. It's concave up from 0 to 4. Oops, let's put that in green so that we match our colors. 0 to 4. And then concave down from negative infinity to 0, union 4 to infinity. And now we have everything we need. Now let's apply it on the graph. So these numbers that we find here are critical numbers and the possible points of inflection we want to place on the graph. And it doesn't have to be perfect. They just need to be where they are. So it's 0, 4, and 6, and 6. So we're going to go at 0, and then 1, 2, 3, 4, and then 1, 6. So there we go. So 0 is at 400. 6 is at 832, and 4 is at 652. So let's put those in their respective places. So that would be 0, 400. And then we have the other one at 4, and it's a little bit higher at 652. So right about there. So that would be 4, 652. And then the other one is at 6, 832. So we're at 6, and then it's all the way up another 200. So they're almost like that nice little, it's not really a line, but they both go up the same amount. Pretty close to it anyways. There we go. So that would be at 6, 832. And that is our max. We already know that. So now connecting these points, we already know that's a maximum right there because of what's going on. And you can already see the shape. It's going to increase to 0, and then increase from 0 to 6, and then decrease. And so we can already put that concavity in at 6. 6 is after 4, and it's fully concave down there. So if we pick on blue, right there, we already know that's our shape for our max right there. And then the rest is just filling it in with the concavity. So between 0 and 4, it's concave up. And between negative infinity and 0, it's concave down. So from here, we know it's concave down. See, when you have 2 points here, you have 2 choices with our polynomials to connect them. We can either go concave up, or we can do concave down. And so all you have to do is look at your picture and it tells you what to use. So this is concave down as we go from negative infinity to 0. So that's the shape we draw. And then from 0 to 4, it's concave up. So we're going to be drawing that connection between the two. So like that. Make sure you make it exaggerated too. Don't just draw like a line connecting them. Exaggerate it. So a nice exaggerated concave up. And then from 4 on, it's concave down. And you can already see that shape. So going from that point, from 4 to 6, you have to have that concave down. And then from 6 on, it's also that concave down. So you can full on see the concavity here. That's down. And that's up. And that's down. So we're just tracing them as we move through each, and then you verify it with your calculator, and you can fully see that concave down, concave up curve, concave down. So even though it looks like a line, we're making it a lot more exaggerated to make sure that it's verified as concave down. If you have any change in there, it's not drawing it concave down. So if you did this as you connect it, you just drew 2 concaves. You got a concave up here and a concave down. So you always want to make sure, sorry, that was a concave down and a concave up. You want to make sure that it's always fully what it's supposed to be. That's concave down. as you draw it. So don't just copy the graph that the calculator gives you. Make sure you have the facts to back it up. Thank you.